So homework 1.7 was all about linear independence. And what we saw at the beginning a couple of videos ago is that linear independence in a set of vectors means that a matrix will have a pivot in every column. It means that that matrix with a pivot in every column, if that matrix is in a consistent equation, then the solutions will be unique. The other characterization of a linearly independent set is that no vector is a linear combination of the other vectors. So in that sense, we need all the vectors. So here's the other way we can determine that. A set of vectors, let's let v1, v2, up to vn be a set of vectors. Let's say that these vectors are in Rm, because I'm going to make an m by n matrix soon. So let's suppose we have a set of vectors in Rm. And the first thing we come across in 1.7 is this definition of linear independence. So if the equation x1 v1 plus x2 v2 plus xn vn equals 0, if this homogeneous vector equation has only the trivial solution, if that homogeneous vector equation has only the trivial solution, then the set of vectors is linearly independent. So let's pause and write that down. This is what we as mathematicians decided our definition of linear independence should be. And then let's associate it with all the other ways we think about linear independence. So we've set up this vector equation, a homogeneous vector equation, and we're saying this has only the trivial solution. Then the set of vectors is linearly independent. And this has to fit with our notion that one of the vectors is not a linear combination of the other vectors. This has to fit with our notion that a matrix has a pivot in every column. All right. So this definition must fit, spelled must wrong, with our intuition about linear independence. So this is a definition, and it should fit with everything that we know about linear independence already. So this should be equivalent to saying that one of the vectors is not a linear combination of the others. No vector is a linear combination of the others. No vector is linear combination of the others. It's also going to have to give us, there's going to have to be some matrix involved. This is also going to have to mean that there's a pivot in every column. So that's another linear independence thing. Ooh, I'm going to have to, if I'm going to talk about the columns of a matrix, I'm going to have to define a matrix. So the matrix V1, V2, Vn must have a pivot in each column. That's another characterization of linearly independent sets. Since the equation itself is homogeneous, it is definitely consistent. A homogeneous equation is always consistent. Because if I just make zeros for all the coefficients, I'll definitely get 0. This definition says that's the only way to get 0. So a homogeneous equation is always consistent. Because of the solution, I can always use the solution x1 and x2, xn equals 0. A homogeneous equation is always consistent. The vectors are linearly independent if this is the only solution. So the set of vectors is linearly independent if this is only the solution, the only solution. This is called the trivial solution. If you want to get a bunch of things to equal 0, just use 0 for all the weights. So this is the trivial solution. All zeros. I want this to equal 0, just 0 everything else. Take your ball and go home. So the homogeneous equation is always consistent because the trivial solution is always a solution. We're wondering if this is the only solution. If the set of vectors is linearly independent, then this will be the only solution. There'll be no non-trivial solutions to the homogeneous equation. All right, so that's what has to happen. Those are our characterizations of linearly independent sets. And this is one of the ways we can characterize linearly independent sets. The two that I stated here under the intuition category, we want to think of it as no vector is a linear combination of the others. Because if one of the vectors is a linear combination of the others, I don't want that vector in my set. That's extra. And I want to make linearly independent sets. I want to make a lean set. I don't want Legos that are 3 high, because I could just make those out of the short Legos. Actually, I totally want the tall Legos, because otherwise I need 3 times as many Legos, and things get just ridiculous. If all you have are the little flat 2x1s, it's going to take you a long time to build anything. All right, let's take this and take this information and go into some of the problems from homework 1.7. Remember, this is the thing that we're thinking about. Everything in 1.7, questions about linear independence, are all related to this concept. Is one of these vectors a linear combination of the others? Does this matrix have a pivot in every column? There's not. No, just use the pivots in your explanations. Pivots should be where your explanation ends. Whenever you're writing an explanation, you always want to write your explanation as small as possible. If you're going to refer to the rightmost column, you have to be referring to an augmented matrix. If you talk about the rightmost column and you're not looking at an augmented matrix, then you're making a mistake. The only time we need to invoke the rightmost column is when we're dealing with an augmented matrix. So, any questions on the homework from 1.7? What do we want to go over? Is there anything I want to do? (10 and 36). So in problem 10, problem 10 is cool because it's got the H in there. and we want the two versions of things. I want V3 to be in the span of V1 and V2, and for what values of H is V1, V2, V3 linearly dependent. So what's the difference between those two questions? In problem 10, while I'm writing these vectors down, so I got V1 is 1, -3, -5. V2 is -3, 9, 15. And V3 is 2, -5, H. All right. So question A, part A says, for what values of H is V3 in the span of V1 and V2? And for what values of H is V1, V2, V3 linearly dependent? Okay. So what do we notice about these three vectors first off? There's something that jumps out about these three vectors right off the bat. Mechanically, we could just drop these into a matrix. We can drop these two in a matrix and then find the reduced or echelon form. But that's what we want to notice. V1 and V2 are multiples of each other. Notice that V2 is just -3 times V1. So we've already cut a lot of the work out of before we even grab the calculator. If we notice right away that V2 is just -3 times V1, we're like, oh, calculator, I'm sorry, I don't need you. So first thing we want to notice, note, V2 is just -3 times V1. So that means V1, V2, V3 is definitely a linearly dependent set. The set of vectors V1, V2, V3 is linearly dependent. That's a characterization of linearly dependent sets. One of the vectors is a linear combination of the others. And look how many, whatever row operations we're going to perform, whatever calculated buttons we're going to push, V2 is a multiple of V1. So the set of vectors V1, V2, V3 is linearly dependent. And this is for all values of H. So that's a linearly dependent set of vectors for all H. Is V3 ever going to be a multiple of V1 or V2? That's redundant. Is V3 ever going to be a multiple of V1? No. V3 will never be a multiple of V1. So H could never be in this, for all values of H, V3 will never be in the span of V1 and V2, because V1 and V2, pretty much the same vector. All I need for that is V1. Any combination that uses V2, I'll replace V2 with -3 V1. So by making this note, noticing this right away, that V2 is already a multiple of V1, we can see that V1, V2, V3 is a linearly dependent set. We see that V3 is not a multiple of V1. V3 is not a multiple of V1. So what was the question? How is it phrased again? Phrasing is so important. For what values of H is V3 in the span of V1 and V2? So V3 is not in the span of V1 and V2. Notice that the span of V1 and V2, since V2 is a multiple of V1, the span of V1 and V2 is the same as the span of just V1. The span of V1, V2 is the same as the span of V1 because I don't need V2. It's a multiple of V1. It's a combination of the other vectors, and I can always get rid of it. But V3 adds something different. Because V3, the first entry is 2, which is 2 times the 1, but -5 is not 2 times -3. So V3 is never going to be in the span of V1 and V2. V3 is not a linear combination. So in that regard, we don't need to perform any row operations. We can already see what the reduced or echelon form of this matrix is going to be. If we were to do those row operations, if I look at this matrix, first column is 1, -3, -5. Second column is -3, 9, and 15. And the third column, 2, -5, h. If I find the reduced or echelon form of this matrix, what's the first column of the reduced or echelon form of this matrix going to be? One, 0, 0. What's the second column of the reduced or echelon form going to be? -3, 0, 0. Because the second column is just -3 times the first column. And what's the third column? This is not an augmented matrix. This is just the matrix V1, V2, V3. What about the third column? Nope. The reduced row echelon form. Got pivot here. Second column, not a pivot column. The third column, since we see that the third column is not a combination of the first two, because it's not a combination of the first one, it's going to be a pivot column. And we know what that's going to look like. So the matrix V1, V2, V3 does not have a pivot in each column. So the set of vectors, V1, V2, V3, is linearly dependent. Anytime we can avoid performing row operations, we should avoid performing row operations. How's everybody okay? All right. So a question came up, is this an augmented matrix? If we could ask the question, is V3 a linear combination of V1 and V2? And we could think of this as an augmented matrix. If I did think of this as an augmented matrix, I would say that the rightmost column of this augmented matrix is a pivot column, and therefore the equation is inconsistent. So if we did want to think about this as we could say the equation x1 v1 plus x2 v2 equals v3 is inconsistent, since the augmented matrix v1, v2, v3 has a pivot in the rightmost column. It could be an augmented matrix. In this case, I wasn't using it all as an augmented matrix. I was just looking at this as a set of vectors, but it would be perfectly reasonable to start talking about this augmented matrix, V1, V2, V3, instead of just the matrix V1, V2, V3. Any questions? This is why if you're going to talk about the rightmost column, you have to, and your sentence does not have the word augmented in it, something's missing. How's everybody okay? It's like so many rules to follow. So there was another question. 6 and 42. The H would have gotten canceled out because I would have taken this 1. This was a 7. Someone said that this last column, if we do these two row operations, would lead us to 2, 7, and an H plus 10. So then I would just take this row, divide it by 7, and then multiply by negative H plus, minus 10, and add it to the third row and cancel out the H. So the H would have gotten canceled out when we pivot in the second row. We should also note that it's a lowercase h, not an uppercase h. Don't shout your variables if they're not matrices. Any questions? Cool. Incidentally, that's something that I absolutely do. Most of the time, you're going to be typing your answers to me, but so I don't know if any of you write in all caps. But if you write in all caps and you're in a math class, it has to stop. You can't write in all caps. Lowercase b might be a different thing than uppercase b, so be very careful. Because if you write an uppercase b when there's no uppercase b that's been defined and it's supposed to be a lowercase b, I will look at it and I'll be like, oh, what's b? And you're like, oh, you defined that. It's like, oh, no, I defined a lowercase b. And then I'll be like, oh, why are you shouting at me? And all the architects in the room is like, oh, but we have to write everything in all caps. We're architects. So in 36, we're given 3 vectors in R3, and we're told that V3 is not a linear combination of V1 and V2. But that does not mean that the set of vectors V1, V2, V3 is linearly independent. We have a counterexample right here in problem 10. Asking for 36 right after 10 is perfect. I should give you all bonus points for that. Because here's an example of a V1, V2, V3, where V3 is not a linear combination of V1 and V2, but the set of vectors V1, V2, and V3 is still linearly dependent, because V2 is a combination of V1. So excellent question. Thank you for that. It should give you bonus points. And in 42, repeat exercise 43, oh no, 42, big giant matrix. This is definitely where you're gonna wanna bust out your calculator. Construct a matrix B with the property that the equation bx equals 0 has only the trivial solution. So if bx equals 0 has only the trivial solution, that means the columns of B must be linearly independent. So what we're going to do is take the matrix A, find its reduced to echelon form. Don't do it by hand. If you do that by hand, I'm going to be incredibly disappointed. Unless you're just trying to flex on everybody, I don't know. Find the reduced to echelon form of A and pick out the pivot columns. So B should just be the pivot columns of A. So that's 42. B is the pivot columns of A. Note that B is the pivot columns of A, not the pivot columns of the reduced row echelon form of A. The pivot columns of A, not the pivot columns of the reduced row echelon form of A. So the first column in B should just be the first column in A. 12, -7, 9, -4, 8. Ooh, that third row means you might be able to do this by hand. Divide the third row by 9 and move it to the first row, and then use that to pivot if you want to do it by hand. And just flex on everybody. Any questions? How's everybody okay? Right now, my expectation is that you might be a little bit stunned because when I'm just sitting at my kitchen counter, I don't really see everybody and I just keep on going. So I don't take breaks. Like if we were in a physical class, first of all, in your calculator, put the whole thing. 1, 2, 3, 4, 5 by 1, 2, 3, 4, 5, 6. 5 by 6. You're gonna have to put in a 5 by 6 and find the reduced echelon form. You don't know which columns you're gonna want to pull. It needs to be 5 by 6. If we were sitting in a physical classroom, then I could see that everybody's like all fading out and falling asleep and passing out and like crying and stuff like that. And I know that it's time to take a break. But here I'm just like, oh, I'm all alone. I'm talking about math and I'm having fun, and you all just have to keep up. So that brings up an important point about calculators. The TI calculators will not perform row operations if your matrix has more rows than columns. This is not because you can't perform row operations on a matrix with more rows than columns. This is because Texas Instruments has some kind of serious flaw in what they're asking the calculator to do, and I don't know what it is. Your calculator should absolutely be able to reduce a 5x4 matrix. But for some reason out in Texas, they don't know how to do that. We can't find a solution set for an overdetermined system. What's going on here? So, I'm sorry if you're from Texas. Not for what I just said. I'm just sorry you're from Texas. I'm just kidding. Gosh, everybody takes things so seriously. Could be worse. I mean, you might be from Texas, but I'm from California, so there's that. All right, let's pause the video and talk about next steps. All right, here we are. The problem with using this camera is now we all have to look at me, which is unfortunate. Here's the embarrassing thing about, here's an embarrassing thing about me, because you should always know an embarrassing thing about your professor. I was born in California, and I've lived in California my whole life, and I don't speak Spanish. That is embarrassing. There we go. Now I'm in space instead of my living room. Technically, I'm still in space. I'm just in the living room portion of my space. All right, so we did a lot of stuff today. We didn't do everything that I had planned to do because we will never do everything that I plan to do. You always plan more than you're going to get through. Dungeon Masters, take note. Always plan more than what you're going to get through. Because you just have 5 encounters planned and know that you're going to get through 2 encounters. Because your players are going to see something and they're just going to go all paranoid about it. And they're going to spend half an hour in a room because you described a picture on the wall on the spot. True story. I had a bunch of players. They're exploring a dungeon, and it was a storeroom, and I started describing what was in the storeroom. They spent 45 minutes examining a bunch of jars. It's like, well, what's in this jar? I'm like, well, it's strawberry jam. Like, oh my God, let's get all the strawberry jam ones. Yeah, they never want to do the thing that you plan. Never decide what's going to happen in a session before the players get there, because the players are like, well, because last week you set a whole thing. We're going to go adventure to the crypt underneath the swamp, and you built up the crypt underneath the swamp as the big thing, and that's the big thing that we're going to look at. And the players are like, well, we're going to stay in town. The town that all you have for is a name, and now you're going to have to improvise. In which case you should just attack the town with orcs. All right, but enough of that Dungeons and Dragons stuff. That's why on the message it's always going to say we're going to go over homework 1.5, 7, 8, and 9, and students are going to be like, oh, no, we're not. We're going to stay in town and talk to the merchants. We're going to spend a half hour buying rope. So what you want to do for the remainder of the week, since we're not meeting again until Monday, you need to continue working on homework 1.8 and 1.9. That's where we're talking about transformations. All we're doing is the same stuff we're doing before. We're multiplying a matrix by a vector, because if we have a linear transformation, then we can always create a matrix that implements the linear transformation. You just got to think of domain and codomain and getting from one space to the next with matrix multiplication. It'll say solve an equation and it'll involve a transformation, and you're just going to be, all you have to do is solve a matrix equation. So you're still asking the same kinds of things. Is one of these vectors a linear combination of the others? Are we going to have many solutions or one solution? And then we'll talk about 1.8 and 1.9 on Monday. What that means is that I'm going to set up, that'll bring us to the end of chapter 1, which means I'll set up a test that we'll do through Canvas that'll take place next week. And then on Monday, we'll talk about 1.8 and 1.9. And then on Wednesday, we'll start getting into Unit 4, which is Chapter 2, which is matrix algebra. Any questions? How's everybody okay? If you have questions on, the test is just going to be a long quiz. It's going to be a recap of the quizzes. It won't be exactly the same as the quizzes, but you'll be doing the same kinds of things. We've had one quiz that was find the reduced or echelon form, write the general solution. We've extended that to include vector equations and matrix equations, and writing not just the general solution, but a parametric vector form of the solutions. So we'll probably have a discussion where, a graded discussion where you have to enter something in parametric vector form. So you can get some practice on that. Everything will be turned in through Canvas. And I usually plan for 4 tests, and then we get through 3 of them. And then the 4th one gets wrapped up into the final. I might modify that to being 4 tests and not have a final. I'm not gonna have a separate midterm. I think teachers that have midterms along with just like chapter tests are just overdoing it. I mean, come on, how many tests do you really want to grade? It's insane. Especially because there's like 80 people in this class. I should say that it's super hard to correct your quizzes, so you should stop submitting them all the time, but it's really not that hard. I think I graded 68 of you. At the time I sat down to grade the second quiz, Reduced or Echelon Form 2, 68 of you had completed the quiz, and I did the grades and the comments in like a half an hour. So this is because you didn't have to write any explanations on that one. As soon as you start writing explanations, then then it all goes to heck because you write weird explanations. I'm not making fun. That's just a statement of fact. I wrote weird explanations when I was new too. Yeah, the test will be next week. I will probably let it go live early, but you're going to be limited on the number of attempts that you have. So usually the first pass through a material, I give you infinite attempts until I close it. And then the second pass through the quiz, the double quiz, that one you get 1 pass through it. So, but you'll have unlimited time. So you'll be able to look at the problems, and you'll be able to look at the problems before you start attempting the solutions. And then you'll be able to spend your attempt at the test just by entering things. And because of that, I think I'm going to be breaking the test up into parts. So it'll look like a lot more work, but instead of 1 test with 4 problems on it, it'll be like 2 tests with 2 problems each. I'll probably also not call them tests. I'll call them something else that's less threatening than tests. Because as soon as you call things tests, people all of a sudden forget what 2 times 3 is. Math students be weird. Yeah. In a physical class, then we would all just sit down and we would all do a bunch of problems together. And I would just sit at the front of the room and just kind of space out and drink coffee and stare at you, acting like I'm watching you, make sure you're not cheating. But anybody that's been in my class, I can't sit and watch you do a test for an hour. I get bored and I leave. No, we're not going to be sitting live and doing it. You're going to be doing the test, and then you're going to be posting it on your own time. Because a lot of students can't show up live. We have a lot of students that aren't in this time zone, and they're like a day ahead of us. So we can't all be in the same room at the same time. Just getting 44 people, that's a little over half. We have a quorum, but we can't all be in the same room at the same time. Any questions? Any other questions? I know I just said the word test all casual, and I'm sitting here drinking coffee, and I'm not even recording this. It's like, oh yeah, there'll be a test next week, and everybody's like, oh crap. But it's just more problems. And I'm also not using one of those test proctor things. I realize that this means that some of you are probably going to, I don't know, get your answers from somewhere else. And I don't know, why are you doing that? What's the point of that? Aren't you here to learn stuff? If you're not here to learn stuff, go do something else. No one's, I mean, especially now, it's 2020. You may have gotten the advice. Here's an important thing. I know we're way over time, but here's an important thing to note. A lot of you may have been told that you have to go to college and get your college degree if you want to be successful. And a lot of you are studying science, not because you care about science and you like engineering and you like building things, but because someone said, oh, you're good at math and science? Go study engineering, you'll get a job. I don't know that that's true anymore. That was absolutely true when I was in high school. I was in high school in the late 80s. In the late 80s, if you were proficient at math and science, go get a degree in engineering and you'll land a steady job that pays well. And I don't know that that's true anymore. Moral of the story, don't take advice about life and how careers work from people my age or older. We don't know what we're talking about. This is especially true for people like me who are academics. The last time I applied for a job was 20 years ago. What the heck could I possibly know about applying for a job in 2020? If by your silence you mean nothing, that is correct. I don't know. How could I possibly know? I don't even know anybody that's looking for employees. If you're not doing this because you feel compelled to do college, and not by some outside force, but some internal force, if you're not doing this because you feel compelled, you have to do this, then you might want to think about doing something else. It's like getting a PhD. If you are getting a PhD to appease someone else, you're never going to finish. People that get PhDs because they have to get PhDs. Internally, there's something inside them that drives them to get a PhD. I want to keep studying this. I'm okay with eating top ramen for the next 8 years while I work on my dissertation because I am driven to do the work. This is how I knew I was not going to get a PhD. They're like, oh, Leach, you're going to get a PhD? I'm like, oh, hell no. I want to get a job. I want to be comfortable so I can ignore people that are suffering. I mean, oh, I shouldn't say that part out loud. Any questions? All right. Fun fact, not all of you have heard this one, but I'm sure you've seen the proof that the more that you know, the less money that you'll make. And I've actually lived in a situation where that was true. I lived in a house, there were 4 people, and one person had a master's degree, that was me. 2 people had bachelor's degrees, and then one person had a high school diploma and some college. He took some college and he's like, oh, no, this sucks, I'm out of here. And the person that made the most money was the one with the high school diploma. This was in the mid-90s where you could get away with that kind of thing. I don't know if that's true anymore. And the person that made the least amount of money was the one with the most amount of education, and that was me. And I made the least amount of money by a long shot. At the time, I was making about 30 grand, and the accountant that I lived with was making 60. So I was making half the money, and I had way more education. So I think the point is, if you want to go to college, if you want to get a degree that's just going to pay off, go accounting. Accounting. Do that. If you're going to go to school and hate what you're doing, you might as well do something that everybody's going to want. The high school guy was a travel agent. And he sold drugs. But he was a travel agent as his main job. And he supplemented it. To be fair, that probably made a big difference in his income. But he actually did, in his travel agent job, make more than me at the time. He was very good at it. What can I say? It was not Pablo Escobar, because then he would have been making a lot more. And the services were not bundled. It's like, oh, hey, I'll sell you some tickets to Tahiti and some drugs to go along with it. So that was not the case. Well, that's not a really steady job either. Any other questions? But like I said, You can't be taking career advice from me. What could I possibly know about what careers are like? Especially so early um, in your academic career. We have to try to prepare. You're preparing for jobs that might not even exist yet. If you're in engineering, that's what you should be thinking of. Don't think about what problem you're going to be working on by looking at the problems that we have in 2020. Think about the engineering problems that are going to be problems in the future. No, careers are not vectors. Vectors are nice and predictable and linear. That's why I like vectors. That's why this class is so great. Everything's all flat. Anything linear, anything flat, nice and simple, easy to predict. Careers are all curvy and messy. Unless you get into academics, in which case all you have to be is lucky. If you want to get into academics and have a nice, easy academic job, then the most important thing to be is lucky. Don't ask career advice for someone in a community college. That is true. I've had this job for 20 years. So like I said, I have no idea what the job market is like. I hear things, but what do I know? This is especially true for boomers, because boomers lived in a different world than we live in now, even the one that I lived in. Boomers could get, this is why it's okay to pick on boomers, because they come from a world where you could get a high school diploma and support a family of 4 in a house that you own with a high school diploma. That was just a fact. And that is not true anymore. I know that much. That is not true anymore. And so when they're like, oh yeah, just wear out your shoes walking around and asking people for jobs. It's like, well, you can't do that anymore. First of all, in 2020, that's rude. I know that much. Any questions? Enough. Oh, wow, disappears. All right. That's it for today. I will see y'all on Monday. I'll send out the new invitation. I'll catch you cats on the flip side. Everybody have a good weekend. If you have questions, post them in the discussions and we'll all try to answer them. I hope everything changes post-pandemic. The last thing that we want to do